Hello, everybody, and welcome to another OWASP Toronto chapter meetup. I'm your host, Adam Greenhill, and I'm here at the UCFE. We're just running a couple minutes late, but we'll update you as soon as we have more information. I believe somebody just joined us on YouTube. Hello and welcome. We're running a couple minutes late. So... Oh, that was... Oops. Yeah, hello and welcome. But yeah, we're just running a couple minutes late. We'll update you when we have more information. Hello all, and welcome to our stream. We're just running a couple minutes late, but we'll let you know when we have more information about the situation. Hello again to the new people that just joined. I've said this a few times already, but we're still waiting to hear back from our speaker. We seem to be missing them at the moment. We've followed up with them, and we're waiting to hear back. They could just be running a couple minutes late. We did reach out to them, but yeah, we'll let you guys know. Yeah, sure. Did you check out Patch Tuesday yesterday?
I did not. Tell me about it.
Yeah, sure. There's a couple of interesting things. There's a DHCP related remote code execution vulnerability within that patch. Yeah, that one's I think the highest patch vulnerability in there. If you guys use like IPv6 in your environment, you should check that out. What else is there?
I was made aware of a tool. It's a Canadian startup that is starting web security testing tool, kind of like Burp or OWASP. It's called Kaido, and I'm going to be looking a little bit more into it. But yeah, it seems to have some features that are similar to, like I said, Burp and OWASP. We'll have to look into it some more. They do have a fairly, I guess, well-defined roadmap, I would say. A lot of feature requests and all of that.
How do you spell that?
CAIDO.
Oh, I spelled it with a K. I got a bunch of One Piece villains. Kaido.io?
Yeah.
Nice. Okay. Pricing is not bad. It's a lot cheaper than Burp Suite.
That's right. Yeah.
Oh, here we have Dmitry. Hey, Dmitry, how's it going?
Hi everyone.
Hey, Dimitri.
Sorry about mix-up with the times here.
No problem.
We're just worried that.
Yeah, no.
Make sure you're okay.
I was sure it's like yeah, it's starting now from some reason, but I see that it's at 6:15. Yeah, so sorry about that. I'll try to make it quick and try to run it in half an hour.
Oh, don't worry about it. I mean, we still have as much time as you need. Like take the time you need.
Oh, excellent. So that's even better in such case. Let me see that you can see me. All right.
Yeah.
That's good lights. I'm ready with the presentation on the deck. Is there a way to put a background here? Are we like online?
Yeah, we're live to streaming to YouTube right now. One thing that I'll just mention as well is that if you do wait for questions or comments, there is a bit of a delay between when you ask and when like YouTube receives it. So there could be like a period of time before anyone actually asks any questions.
Got it. All right. So let me present.
So for folks in the audience, if you have any questions, just type them in the chat, and then if Dimitri can see them, he can answer them, or if not, we'll have some breaks during which we can just read the questions out so that Dimitri can answer them.
Yep. And as always, if you're looking to provide us with feedback or you're looking for CPE credits, there is a form in the description of this video that you can use to register that you've been here. Dmitry, I see that you are sharing your screen, and your presentation is visible.
Can you see it?
Yep, everything's good.
Excellent. So yeah, hi everyone. I'm Dmitry Redman. I'm CTO and co-founder of Cybeats. Happy to be here with you. And we are going to talk today about a software bill of materials, SBOM, and security to transparency you can achieve by following these principles. So let's start. Let me just see that I can switch the slides. Yeah, excellent. Okay, so let's start going over the agenda for the session. We are going to talk about examples of software supply chain attacks. We're going to talk about SBOM Analogy, SBOM History, why it makes sense to use SBOMs, and SBOMs languages and formats. And also we'll touch about differences between VEX and SBOM, and also how we can start with SBOMs. So let's start from the beginning, and let's touch a bit the real-life examples, why we need SBOMs. The first one is known to all of us probably. It's the SolarWinds attack. It happened in December, like it came to our knowledge in December 13, 2020. It was found occasionally by FireEye, which is considered to be one of the best companies for incident response in the world and part of Mandiant. Now, and basically, they found out that their tools, their offensive tools, were stolen, were published, and they start looking. After this lead, found out that there was a supply chain attack that came out from Orion platform, which used by about 18,000 customers, both public companies, government companies across the globe. And the malicious actors were able to go into the SolarWinds systems, sit there for about a year as a dwelling time, and then inject their malicious code into one of the releases of this Orion platform, which was signed with legit software keys, and basically was distributed to their customers. And of course, it trickled big mass in the industry. A lot of companies were affected. A lot of data was stolen, and probably still people are somewhere dealing with that. The next one that we have seen a couple months later on was the QuadCoV supply chain attack that had some echoes of SolarWinds, but on April 1st, in 2021, someone occasionally discovered that this QuadCoV plugin had been used by many DevOps professionals today to measure code, I would say, coverage by testing. It suddenly has a different hash than what was published on the website. And basically, he started following that lead, found out that the binary is replaced. Meanwhile, this binary reached and got into many continuous integration, continuous delivery processes of large companies. It was aiming to get secrets from build servers, which in many cases include AWS keys, SSH keys, and what's not, right? Other type of secrets like passwords. And there was another game over for that for another point for the adversaries, and game over for the companies. Another thing which turned out to be social experiment by a researcher, right? Some guy created a package in NPM that called Dash, and immediately a few days after it happened, like in summer 2021, we could see 720,000 downloads of this package. Package was empty, no malicious code, no malicious intents. However, it was a solid proof that, hey, like people doing typos, human errors are here to stay with us forever. And definitely it was a validation of such type of attack vector on supply chain. Shortly after, in end of 21, we all were surprised by this Log4j vulnerability that everybody spent who dealing with technology, and somehow their company does something with Java or consumes products or softwares with Java, were affected by that, right? Log4j vulnerability, and many of us spent Christmas, New Year's Eve, trying to just identify, hey, how long where we have this thing in our code base or in our software that we installing on our servers. And funny enough, it's still not covered yet. We probably will hear about that in the future years, right? No one knows where it will pop up, but might be related to some significant breach that will happen in the future. And then very recently, in February this year, NPM Repository flooded with 15,000 phishing packages. You remember that Dash from before? Yeah, so the malicious actors these days, they just doing kind of auto-generation of packages, there is a legit package that called async with cdn. They would create one with K, one with Q. They will publish it. It contains malicious code that capable when it's running to land in malware and or communicate with a command control server and help them to leverage it for making more significant attack on the systems. And what's interesting also to know here is that they kind of move to automated processors to do that, right? So it's like really does not involve a lot of sophistication or human, I would say, heavy leverage of knowledge and resources. And of course, 2 weeks ago, we all witnessed 3CX desktop application. Again, affects 600,000 companies worldwide. I mean, I think it was well managed in this case, right? I mean, or we were lucky that it was catched at that moment, but by the EDR solutions. But again, legit software that was signed with legit certificates. It's distributed to Windows systems installed with malicious code in it that was able to land two-stage malware, which is quite complex to execute. But again, the reach, you can see like one little success gives you a reach to, the unlimited reach for your attack or malware. And eventually this thing has 12 million daily users across the globe. So, like most of the companies, there are call centers, and most of the companies, there are some type of, support organizations and companies using it internally for VoIP communication between their employees. So yeah, that's a big one. So definitely enough of examples that we have reviewed. Hey, why we care about software supply chain, why we care about that topic is all, why we need SBOMs in the world. But let's now start looking at how we building our software, right? And those software solutions. So let me see if there's any questions or comments. Not yet. Okay. So let's see how we're building today's software solutions, right? Let's talk a little bit about that. So usually, if we're looking at that, we'll find out that, our modern product, which is, we spent like 2-3 years, 5, 10, 20 years to build, that's how it looks like, right? It looks like from multiple blocks. And if you're looking at 90% of commercial applications today, what you'll find out is that it either has outdated or abandoned open source components. Now, there is a big difference between outdated or abandoned, right? So outdated, it means that, hey, like, it's using some old version, like Windows 7, let's say, so it's outdated. Or abandoned, it means that it uses some open source. Well, Windows 7 is not open source, right? But there's other examples that we can take, like old version of Log4j's example. But abandoned software is really software that not maintained anymore by the open source maintainers, right? So basically, whoever maintained it stopped doing that because he got enough of it or some other reason, and there is no new person who maintains this source code, this open source. So it means that if there is any vulnerability, any even bugs, right, or issues with it, no one going to fix that. And again, the funny thing is 90% of commercial applications has, at least one such component. Now, if you're looking at our product today, right, so this is our product, we will see that we're really developing about 20, 25, maybe 30% of that product by writing our own code, right, that we're familiar with and we know about it. But really the rest of this product that we are shipping out or maintaining or operating consists of not our code, right? Someone else's code. Now here's Steven, right? Steven he's a developer. He lives in Nebraska. He likes cats, open source. He contributes to GitHub. That's his cat, right? And this is a project that he thanklessly maintaining since 2003, right? One day Steven goes to vacation, and meanwhile GoDaddy tries to charge his credit card for his domain renewal. Credit card company decides to decline it, and his domain expires. Then some malicious actor hijacks his domain and takes over his user on GitHub, right? Because he has access to his email now. And malicious code been added to this repository, and it's really game over. all our modern digital infrastructure is depending on these small things. And the question here is, do we know how many Stevens we have, in our code base, in our products, in our software that we build and ship and deliver, or a software that we consume as organizations? The question is hard to answer, definitely. And really, it's enough one bad apple to spoil the whole box, right? And this is how our products looks like. They might consist of many things like microservices, SaaS solutions, containers, firmwares, applications running, but it's enough one vulnerable non-maintained component that to allow someone to take over this application and exfiltrate data and then leverage it for further attack, right? Or as a ransomware or stealing data of the company. Now, SBOMs. What is SBOMs? And now we will start understanding why it makes sense. So really, an SBOM analogy is nutrition facts. Many people in the industry, and this is not correct here, nutrition facts, right? Many people in the company think it's nutrition facts, but it's not, right? It's really the ingredients, right? That little list here that we see on the box, right? That's what SBOM is. SBOM telling us, hey, what are the ingredients? What kind of open sources we use? What kind of commercial software we use, right? What is the version of every open source? What is the version of every commercial solution that we have used as a library or anything else? And of course, once we know that, now we can understand, if we have like allergies, food sensitivities, we care about healthy living, we care about what we eat, right? We now, with the same analogy, we want to know what we're installing on our servers, what we're running in our cloud, what kind of things we're adding in our code, right? Because we like developers are lazy, and I can attest to that, right? We don't like to reinvent wheel. We prefer to use something, but we need to know how, we need to make smart decisions when we're adding or using someone else's code. And this is where really this SBOM comes in place to help us. Now, SBOM itself is a standard, and it was really accelerated by President Biden's administration Executive Order 14028, which came up in May 12, 2021, right? So this was really, I would say, pushed by the Colonial Pipeline breach, which is not related to SBOMs and software transparency or application security or any of these. But what's interesting is that SBOM got its way into this executive order. It was mentioned 11 times there. There were clear intention of, hey, companies need to start using SBOMs, collecting, creating SBOMs, exchanging and transferring SBOMs, right? And that's basically something that, brought to awareness of everyone what SBOM is and what it stands for. And of course, it stands for Software Bill of Materials. Now, after that, after this May 2021, we have seen in February, NIST came up with a Secure Software Development Framework, SSFDF. SP is the document SP 800-218, which says, hey, if you're making a software, you need to start collecting, you need to start maintaining and sharing your provenance data, which really results in SBOMs. Then it was endorsed by the budgeting committee in some node in the US that's called M2218. Now, since we are in Canada, we actually have also a very interesting bill going on right now. It went through 2 readings at the moment, and it will go probably to Senate for the 3 readings. There, it's called C26. So if you're interested in policy making space, please look after this C26 bill. You will be interested to read it, which really kind of resembles what was said in all of this policy in the United States. Now, many people think that SBOMs it's something new, some kind of hype, right, that came in the last couple of years, right, and everyone talking about that, and we see it on LinkedIn, we see it everywhere, right? But really, SBOMs is not something that very recent. SBOM started in 2011. It's really kind of the first seeds, were planted by Linux Foundation when they started using this SPDX open source licenses, right? So they kind of organize the space, they give proper naming for licenses, they maintain database, they made it public, and they're very organized. And then in 2013, we have seen some renaissance in the term of software composition analysis tools that were using this data. Some of them were even capable to tell us for languages like Java what kind of vulnerabilities we have. In 2014, SBOM first mentioned by FDA. It was in context of if you building a medical device and you would like to submit it for pre-market approval, you would need to print a page, like, literally, like it was like printed pages, right, with every single file on the system and its hash, right, and submit it together with that. So in 2018, NTIA SBOM group started the work on the standard itself. I joined a short time after the start, like about 6 months later, to this group, and it's very interesting to work with other colleagues in the engineering space on this standard. We identified then with the group the standard, the languages, which is SPDX, CycloneDX. We started talking about VEX, which became kind of thing of its own, a separate standard. And it really took us a village to raise this child. And in 2021, SBOM was mentioned in the O. Like I think in 2020, we published some paper about SBOM. What is SBOM? What are the minimum elements for an SBOM? Then it was mentioned. Now 2022, multiple global POCs are underway for the standard. CSAF took over from NTIA the ownership of all of these working groups, right? So they kind of helping to organize everything and facilitate the meetings and the logistics. We have seen NIST SP 800-218. We have seen OMB. 2023, we see accelerated adoption for companies that in the space of medical, right? So FDA came out recently and said that by October 1, SBOMs were defined in this. The outcome of this NTIA group will be mandatory, will be required to be submitted, and also we can see a lot of traction in the space of operational technology, industrial control systems, and other like building automation systems, etc. Which the ones that define critical need to provide SBOMs and start having SBOMs ready for sharing by June this year, and for the rest of their software, which is not defined critical, is by September this year. So these days are closing. It's of course like evolving right now in the United States, but definitely it's making its waves through the industry, and we see a lot of companies in financial sector and even in gaming, like very looking at this type of SBOMs and how to generate SBOMs and what to do with them, etc. And then companies start looking at that also in the way of, okay, how we can get value by doing that, right? What we will get in return as a return on our investment into SBOMs. The next thing that I want to mention is that Linux Foundation is very active in this space, right? And they also promoting and got some funding to embrace these SBOMs, right? So they building very clear use cases, they documenting, they also implementing the specification, the specs of this SPDX. We'll learn later what language belongs to what organization and foundation. They also embracing and promoting creation of open source tools that create SBOMs. So if you think about that, the state of the industry today is that if you want to create SBOMs, it's free of charge, right? There is so many repositories and tools that were developed by open source community that you can find one for any type of technology using today. So you can easily integrate that in your CI/CD pipeline, run that script with one line of command line, or add some block to your code, and this will output for you the SBOM for your software that you're building and shipping. And also they're also promoting a lot of education, awareness, and also third-party support of companies that would help to generate SBOMs, and also consume and manage them. When it comes to standard and languages, what's important to know is, from the history perspective, is that we have here really two different standards, right? They work in conjunction with each other. They complement each other, but it's two standards. One of them is SBOM. The other one is VEX. VEX stands for Vulnerability and Exploitability Exchange. It's very easy to understand, right? I have another slide that will show it, but really VEX, it's kind of, if you're comparing VEX to SBOM, SBOM is the ingredient list, right? If you have the ingredient list, you can do the vulnerability analysis, even if you have just MVD. in scope, you will see now 100 vulnerabilities, right? That affecting this ingredient list. However, not all the 100 of them are exploitable, right? In the way how we're writing our software. As example, we may not, calling something that is exploitable as part of my software implementation, so it's not on the execution path of the code. And VEX is really a machine readable way to describe, right, which one of these 100 vulnerabilities are not exploitable and which one are the exploitable ones. Now, let's look at the SBOM standard first. So there's two main bodies there, right? One of them is OWASP, and that's why we're here as well. And the second one is the Linux Foundation. Now, Linux Foundation, they are behind the SPDX format, and OWASP is behind the CycloneDX format, right? A CycloneDX format driven mainly by Steve Springett, a great person. I know him. I met him personally a couple times. And also we have different specs, right? So every language, basically SPDX and CycloneDX, right? They have their own specs. Currently, SPDX stands on 2.3.1, if I'm correct. Soon there will be 3.0 released, and the second spec for CycloneDX is 1.4. 1.5 will be released maybe like in the final release stages this year. 1.6 is another that already coming, right? Been built. So CycloneDX is much more agile, much more flexible, like at least in my opinion, right? Allows you to do much more, and adjust it to the way of the work. SPDX still a little bit, it's a little bit simple and primitive, but that's also one of the benefits there. Another benefit with SPDX is that it's recognized by the ISO Foundation, right? So if you have to comply with ISO standards, you might want to use SPDX. Both of them, by the way, when it comes to formats, both of the languages support XML, like JSON, etc. Now, when it comes to VEX, VEX can be, so the language to implement VEX is called CSAF, right? The current spec is 2.0. Specifically for the VEX, there is a special profile in CSAF that's called Profile 5, right? So if I would like to implement VEX with CSAF, I will use spec 2, Profile 5, and that's kind of where all the definitions and all the, I would say, states of vulnerability disposition are taken from. Now, what's nice and very powerful in CycloneDX here is that CycloneDX can be used for both, for SBOM implementation. So if I want to implement SBOM, I can use CycloneDX language, right, with spec 1.4, but also I can implement VEX with CycloneDX. So usually companies that will use CycloneDX, they will use it for both. If they will use SPDX, they're likely to use CSAF for implementing the VEX. But I have seen different cases where even SPDX and CycloneDX been mixed. The good news about that is, yes, we do have two languages here for SBOM, one language for VEX, but there are a lot of translation tools in the market, right? So we can give to the translator SPDX file, it will produce for us CycloneDX and vice versa, which is great. And even CycloneDX has tools and open sources under their GitHub repository that allow you to actually translate from CycloneDX to SPDX, right? So it's kind of very interoperable, very easy to grasp, very easy to produce and understand. Now, let's talk about SBOM generation. So let's assume that we are interested to create these SBOMs, to start kind of, accumulating them, and where in our process of either DevOps, some companies doing DevOps, some companies do DevSecOps, where in the process are we going to capture the SBOM, right? Where is the best? So basically, we can create SBOM from a repository, right? So if you have GitHub repository, you have the source there, it's possible to trace back and understand all the relationships and all the dependencies and generate an SBOM for you. There is some drawbacks of doing that there, right? Because if you have your repository, usually you will have there all kind of artifacts that's related to your testing libraries and QA, etc. Something might be related to your build. This is not the software that you're shipping, right? You're using this during the build, yes, but you're not shipping it to anyone as a software, so it's not so relevant for your SBOM. But if you generate SBOM there, you'll get all of this noise, right? Now, the second and that's probably the best place where you can generate SBOMs, is really during the build time, right? When we're building the code, because that's where we, splitting and separating between everything. We're creating some folders where only we have our product. We're removing all of the noise around right after the test executed, and now we're kind of wrapping up everything nicely. We have the final zip or assembly file for the compiled code or transpiled code, and that's kind of really the best place to capture SBOM, because that's where it really represents what we are shipping. So we can generate actually SBOM every time we're doing a build. We will generate SBOM. Now there is an option also to create SBOM from the released files, right? So let's say like if we're building a device, like IoT device, we have a firmware, right? And this firmware can be fed to a binary analysis tools. Most of the tools out there that are capable to take this binary, analyze it, and produce meaningful SBOM, they are commercial tools, right? So we will have to pay for them. But really, it's also has some issue, right? And the issue here is when we're doing binary analysis tool, there is a level of precision to which this tool can go, right? And you will get somewhere, between 80 to 90% precision. As example, like it will tell you, hey, like you have OpenSSL, but it might not be completely precise with your version. And in some cases, if it's false positive, that's fine. I prefer to know more than less, but if it's false negative, that's a different problem, because I'm going to be aware of some issue that I might have, right? Or some weakness that I have in my software. And it's a good thing to actually be precise there. So again, it's possible to do it in release. Where it's really mostly applicable to create these release SBOMs or binary analysis SBOMs is usually when we have some legacy product, legacy software, legacy code. Some companies have like old products, like 20 years old. No one even know how to build them. No one even know where the source code of this product in many cases, but do want to have SBOMs. They do want to know what inside there approximately. So that's a really good place to apply this type of tools. I'm going to maybe stop for a second to see if there is any questions or comments. All right. Great. So the next slide we'll talk about SBOM types, and really here that's kind of the next evolution of this these places where we'll take SBOMs, right? Really, if you think about that, we will have in the future design SBOMs. Before we want to develop software, we would create a design SBOM that will list all of the ingredients, all of the dependencies that we are intending to use, and we will use these SBOMs to run it through some risk validation or risk analysis tool to tell us, right, actually which components are good, which components are less good, or identify this type of component we mentioned before, right? You remember these 15,000 of NPM packages, right? We would like to have this design SBOM to tell us, hey, like you made a mistake here. You written sync with Q and it should be with C, right? The Q one is malicious. So we would like to do that, right? The next, before even we written one line of source code. The next one is source code. We discussed about that, right? The build time SBOM, same thing, nothing changed. Analyze really replaces the release SBOM, right? So that's kind of something that we derive from analysis. But there are two new types of SBOMs which are very interesting to know about. So one of them is really deployed SBOM, right? So it's actually kind of a server SBOM. So we have a server that's running multiple applications and containers and Kubernetes cluster and what's not. We would like to capture the whole SBOM of the whole server, and this will be probably more related to the EDR tools, right? That will be doing anomaly detection. That will be doing using such type of SBOMs, capturing them, relaying them back, and then helping us also to understand what's our software assets, right, that we're running on servers. The other SBOM is runtime SBOM, right? This one is really similar to the deployed SBOM, but it's just going to focus on what is really running in the memory, right now on the server or over a period of time, and will give us a more precise picture of, hey, like that will tell us, okay, this is the things that really expose, this is the thing that really imposing risk for us, and of course, it will help us to identify risk in real time. It will help us to fix and correct these things. And again, this is more will go to the endpoint detection response type of tools, or as example, CWPP tools like cloud workload protection platform tools. If you're looking at SBOMs and the VEX use cases, right, why it makes sense, really, like it's about aligning with globally recognized standards instead of some tool, right, that we might have, knowing what we have, knowing inventory, getting the transparency, understanding our transitive supply chain, right, so how Log4j gets into our software, right? The ability to democratize and own the SCA data. Today, when we have SCA tools, they take the data and they give us back value. But here, we will own the data locked in the SBOMs, and then we can give it to SCA tools or other tools that properly provide us the value. Optimizing MTTD and MTTR are for cases like Log4j or cases like SolarWinds or C3X, right? This will help us in a seconds to analyze and say, hey, like we have this specific software risk here, 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 and here. And the next is accelerating vulnerability management and kind of transitioning from point in time to continuous. Because if we have SBOM and we know the ingredients, we can continuously check and monitor, right, to see if there is a new vulnerability that affecting our composition of software. And another one is finding open source software license violation, IP infringement, which is very important today for a company. And eventually it will all lead to better risk insight and much faster communication of risks and also much faster addressing of risks. And this is nice picture, right? We probably familiar with it from many organizations, not all of them, but many of them are like that, where product security developers playing hot potato with each other, with throwing this bad apple that has vulnerabilities, because there's a lot of miscommunications. It requires attention to details, right? It requires proper communication. We cannot tell developers, hey, fix something in library of XML to doc, and they would tell us we're not using it, right? But actually XML to doc comes to us to 5 transient layers of dependencies, right? So we need to be precise when we're telling to developers that something needs to be fixed. And also we need to empower the developers, right? We really want them to be able also to access and see the full picture. Now, let's talk a bit more in depth about SBOMs, right? So if you remember, I told you about this NTIA group and the document that we published from that group, right? That has mandatory data. I call it mandatory. We called it back then minimal data, but it's really mandatory, right? It's important that when we're creating SBOMs, we have the supplier name, right? So who's behind the software? That's the software provenance and pedigree. Software component name has to be precise. OpenSSL, not my OpenSSL, right? Software component version, right? 1.11.5 or whatsoever. Dependency relationships, right? So it tells us how this specific dependency gets into our code, through which dependency transient layers. Assembly timestamp, right? So when this SBOM was generated, what tool was used to generate SBOMs, and eventually it's very important also to have unique identifiers such as PURL, which stands for package URL, and this is a very generic way to identify software components in the world, or CP that we all familiar with probably from NVD, right? Or hash, at least hash. Another thing to pay attention for is really SBOM quality. A lot of common SBOM quality issues that we are seeing from many tools is really like the SBOMs are invalid, right? They're being produced by a tool that has a bug, and eventually the SBOM is not by the spec, right? Sometimes we find circular dependencies, which is kind of endless loop, right? You have component A depending on component B, and component B depending on component A, and now you're in like endless loop of dependency. Missing data, right? So we're not describing properly in these SBOM files, right? What is the application name, like what this SBOM file contains, like what it describes, what it means. And other things are mentioned before: PURL, hashes, CPs, versions, no relationship, right? Some SBOMs are just flat. So you see SBOM, it says, hey, I have application A, and it has like 1,000 libraries. But these libraries, they depend on each other, but these dependencies are not expressed in the SBOM, so there is no way to understand how everything gets into your software. And other things like missing low-level software components, sometimes just it describes the high level of the things. There is no assembly tools as well specified, and these all things are really affecting the SBOM quality, because we produce SBOMs, and maybe we need to produce them or we want to produce them, right? But when we're giving them to someone, if this SBOM doesn't have good quality, they will not be able to consume it, right? So they will get back. It will get back to us. Now we're getting to this point where I'm going to mention the SBOM and how it ties to VEX, right? And this is an interesting slide to understand. So as I mentioned before, SBOM, right, it stands for your ingredient list. And that's the whole thing. Now, if you apply to this ingredient list the vulnerability from any vulnerability database, right, such as NVD, right, you'll find out this area in the middle that will tell you, okay, this part of this SBOM, these ingredients in this SBOM are vulnerable, right? But we don't really know what is the difference here yet between vulnerable and exploitable, and this is exactly what VEX helps us to define, right? It helps us to tell us that only this piece, only these like 5 items, or only these 3 vulnerabilities that affecting these ingredients are exploitable, right? And it allows us in machine-readable format to communicate this with our customers, with our, or let our supply chain to communicate it with us. It also allows us to communicate things that we don't have. It's part of our design, right? So, for example, log4j, we can say it's exploitable, it's not exploitable, or we can also say this is this little arc here on the outside, right? Can say we don't have log4j. It's a good way to do that, especially if we have customers that rely on us. We don't want them to call us 1,000 times to our call center and ask, hey, like, do you have log4j, right? After they learn about that, we can just communicate it in VEX document and say, hey, we don't have log4j. This is our security advisory, basically, right, that we're publishing. No, there is no log4j in our design. And eventually, producing SBOMs is something that easy. It's a commodity, right? You can start producing SBOMs whether you select SPDX as your language or CycloneDX, right? You can use commercial solutions. You can produce it for so there's like native integrations for most of the package managers or technologies out there. So it's quite easy to do. Then really once you generate it, you also need to think about managing SBOMs, right? And actually you need to store them somewhere. You need to monitor them. You want to see on top of them data analytics, right? And you want to bring and enrich data from multiple sources, such as NVD, such as GitHub, SPDX, and others. And eventually, what SBOM allow you to do, and this is the layer of SBOMs, it gives you universal interoperability, right? We are some of us working in large companies, right? And as such, we have many tools, we have many teams that made different decisions across many years, and people using different tools. Some will use Veracode, some will use white source, some will use open source. But good thing about the SBOMs is it's really a standard, right? Think about like a USB drive. You can plug it in anywhere, right? Same thing with the SBOMs. Once you move to SBOMs, strategically now, you own the data. You can plug it in regardless to which format, right? If you used one of the standard languages, CycloneDX or SPDX, it doesn't matter which format you have. You can plug into any management or any solution that's capable to ingest them and then providing value on top of these SBOMs. Now, we're usually seeing, especially working with a lot of companies that use SBOMs and utilize SBOMs and generate SBOMs, we see kind of some trends, right? And we build this maturity model that helps to self-assess from SBOM generation through SBOM management, then SBOM streamlining the organization, and then kind of graduating to SBOM exchange. So now you can kind of send and receive SBOMs, right? And automatically, and then eventually SBOM operations, right? That allows us now to actually monitor our software on our servers, that it's not changing, the integrity is intact, right? And everything is okay. No one modified the software. So that's the various stages in the maturity model, right? Most of the market today, I would say, they are in this area of SBOM generation, graduating to SBOM management stage, right? So that's kind of where we see the market today, and some of the companies actually moving to SBOM streamline, right? To the level of giving the organization transparency, letting like development teams and developers to access data derived from these SBOMs, right? To query these SBOMs, to get analytics conclusions from these SBOMs. So that's something that's going on in the industry. The one slide before the last I want to bring up is that there are a lot of SBOM workstreams and groups. If you're passionate about this topic, right, I welcome you to join one of the CISA groups. It's free to join to anyone. It's open to the public. You can you can go to the CISA website, look for SBOMs. You can send them an email, ask them to add you to the meeting, right? If you cannot figure it out, shoot an email to me or LinkedIn, and I'll make the connection. But there are like 5 groups right now that managed by CISA, and there are some also independent groups like SBOM Standard, which is really like that's the piping to share SBOMs, SBOM forums, SBOM VEX Generation for CISA Healthcare POC, Healthcare SBOM POC, and others. And these meetings are happening weekly, so definitely welcome to everyone to join and at least to listen, right? You don't need to bring up anything there, you just can join and listen. Another good resource is a resource that we created. If you Google for Cybeats GitHub, right, you'll get to our GitHub repository. We have a huge list of softwares, and I can show this here to you. Actually, I'm showing a different tab, but basically you can go there and you can see a list of, hey, I'm using Java. This is the free SBOM generation tool that they can use. I'm using Maven. That's what I can use, right? I'm using Gradle, that's what I can use, NPM, Python, pip, and others. So we listed there. We tested most of these tools. They're producing quite adequate results. So you're welcome to go there. It's open to anyone and get part of this knowledge. And we are getting to the end. Thank you very much for listening again. And just to remind everyone to set up multi-factor authentication on everything you do and have passwords. That's always good practice. Thank you very much for listening.
Yeah, thanks a lot, Dimitri. That was really helpful.
And thanks for the reminder for MFA.
I always do that. It's my personal mission.
That's awesome. Looking through the comments here, it doesn't look like we have any questions from the audience. Oh no.
Did we lose Dimitri?
We lost Dimitri. Oh my gosh. Oh boy. What a day.
It's okay. Let's see if he can join back in.
I rejoined.
Oh.
I had to refresh the browser. Something weird happened here.
No worries.
It's okay. In the meantime, if there's no questions from the chat, but maybe I can just ask one right now. Dmitry, do you have any actual examples of SBOMs you can show from this open source project or something, just to visualize, help the audience see what SBOMs are actually?
Yes, so absolutely. Let me just open here some for test examples. So see if I can present my whole screen. I can do it entire screen. Perfect. Can you see it? Can you see my screen now? Yeah, you can probably see myself.
Adam, can you?
Oh, my bad. Sorry. Yeah, here we go.
All right. Oh, that's nice. And let's move. Okay. So this is actually our tool that we're developing. So I'll just take one of our SBOMs here that have, and I'll download it and we can have a look and explore it, right? So let's open it up in Sublime. Yeah. So this is an example of SBOM, right? It has a lot of lines, right? Usually, you'll find it as JSON, but what's important? Can you see this? Can you see my screen now?
Yeah.
Maybe if you can just zoom in a little bit for people to
zoom in. Let me see. Where's the zoom here? Good question. Zoom. Okay, and so zooming. Yeah, I never did that in Sublime actually to zoom in, but
you know what? If it's
Control plus.
No, it's not.
Oh, it might not be for Mac.
Yeah, I'm using Mac, so Command Plus. Oh yeah, Command Plus works.
Oh,
okay. So can you see it now?
Yep.
Much better.
Okay, so usually when you're looking at the SBOM, right? So that's kind of the whole SBOM. You can see 1,200 lines of data. The first line will tell you what is the BOM format, right? So it tells us Cyclone DX, right? The second line here tells us which spec it's aligned. You remember I told you like 1.4, 1.5, 1.6, that's what it is, right? This one says it's kind of an old one, old spec 1.3. Then it has serial number, which has to be unique, etc. But what's interesting is the interesting part starts in two main things here, three main things, right? So there's like three blocks which are important. The first block is the metadata. So if you look at the metadata, you can see there's a timestamp. There is a section about tools. So you remember like one of the minimum elements was the tool that was used to produce the SBOM, right? So it gives usually the vendor of the tool, right? The name of the tool, the version of the tool, and some hashes of the tool itself. It's like not mandatory, but it's good information to have. Then there is the section of component, right? So here it tells us which application or product it describes, right? And what's important to know here is, paying attention here, the group is basically like a namespace, right? The name, that's the name of the project. Version, in this case, it's development, like dev version, but it could be 1.1, let's say 500. Then there might be licenses, right? In this case, there is no license. It's kind of proprietary software, but also proprietary licenses can be described. That's the pool package URL. So it says it's kind of Maven, distributed through Maven. That's namespace, name of the tool, at the version, right? And there is also qualifiers that we can add. There is like different types of qualifiers. Now, I really urge everyone to go and at least read the Perl. Just Google Perl spec, right, on GitHub. You can read it. There is all the information there. Just get to familiarize with that, because this is really the future for identification of software, right? Generic identification of software and the ability to map between software and vulnerabilities. GitHub are already using it extensively. OSV using it extensively as well, the Perls. So I think if you are in the application security, offensive or defensive, it's good thing to know about. And the next thing is very important is type, right? Here it's application. And there's like it's like saved words, right? There's like application, container, firmware, and I think there's hardware also. There's like 5 or 6 types of hierarchy. So if you're thinking about this metadata component, which is one component you see here, right? That's kind of the outer shell of our software. Now, I'm going to close the metadata, right? Because we looked through it. Now, the components, this is now says, okay, now inside this shell component, there is a lot of smaller things, right? That's kind of my dependencies, basically. You can see here every single dependency described, right? And there are multiple of them. It's an array of these dependencies. And for every dependencies, it tells us who's the publisher, as example, right? Who's the group. And this is a good SBOM, right? This is a nice SBOM that was produced by open source tool of Cyclone DX. It knows to bring the right values, the right data into it. So this is why it's high quality. As you can see, what's the version, what's the description. Scope here is like optional, but there is like hashes of everything. There's the license, right? Apache 2.0. There's the pool, which is very important to identify the software. There is external reference data, right? Like issue tracker, version control, build system, mailing list, website, what's not, right? And of course, there is a type which says, hey, this is a library, right? So it's a library that is a dependency of our outer application. So far and so on, like you will see there's like every single thing here is in a library. But eventually this assembly, right, describes to us all of the dependencies in these components. And this is the components array. Now, there is third item here, which is also very important, and this is the dependencies, right? So as example, if you remember, I told you about flat SBOMs. If I didn't have these dependencies data here, right, it would be considered as a flat SBOM because it doesn't tell me that log4j is wrapped in some other .jar library, and this .jar library is used by my main component, right? But these dependencies actually explaining to us and telling us, hey, like, this reference, right, and this reference by tool here, ACB tools, it depends on all of these packages, right? And then every single package can be depending on other package. Like here, right? Here is example HTTP component, HTTP client, depends on HTTP core, commons login, commons codec, and we have all the versions. So this way we can build whole, transient dependency layering properly in the SBOM, so we can understand how we're getting some open source into our software. Does it answer the question?
Yeah, absolutely. This was very helpful to visualize.
Just one question on my end. Like, say you had your SBOM, could you see like where it's being used, like what part of the code is being, that leverages that library, for example?
So this is exactly where the use cases are coming in place, right? And where we need management tool for SBOM, right? Because you can write a lot of scripts to query this data. Right. So imagine yourself now having, a folder with multiple folders and a lot of SBOMs, and now recursively you need to write some script that, finds some string like log4j, and now it shows you, and then it scans every single occurrence of other libraries, understands on the links. I mean, it's hard to write something like that, right? I mean, possible, hard and complex, and then maintain it, and it's not visual. I can show you how it happens in our products, because that's kind of what I'm doing in my day job.
Right.
So let me just show you how simple it is, right? So let's take this, we call it fire drill, right? And let's say I want to find log4j. It's a great example. So I'm just typing here log4, and it shows me, hey, you have log4 and nugget, and maybe if I let to it j, it will remove the nugget. Now it shows me all of the log4js that I may have. So we know that log4j core, that's the problematic one, right? And we remember this version. I will never forget it, 214.1. And just one click here, clicking on dependency lookup now calculates for us and tells us very clearly which containers of ours are including it, which applications that we have built, including the log4j, which products of ours are including it, and it also shows us the transient passes, shows us kind of how this thing gets there, right? So this is one of the examples of such query, and again, this query been done on this SBOM data, right, which is at scale. So you can script it yourself. There are some tools, right, that also allow you to do that, which are, by the way, free, like dependency trackers example, and which probably can give you similar results.
Okay.
And another thing that might be interesting as well is, let's see if I have. Let's say you learned about SolarWinds and you want to know if, hey, are we working with SolarWinds? Are we getting something from them? Oh, yeah, we do have SolarWinds. We have one application that we're using. One click on dependency lookup tells you which applications you're using, right? So we are using like Orion platform, and it's part of infected platform, and it's actually used in something that's called pet feeder, right? If I go here to pet feeder quickly, like I can see the product and I can see like, hey, I'm using this infected platform. There is really Orion platform thing here going on, right? So I can get all this data very quickly, very immediately, and it shows you all the vulnerabilities and everything else. So that's type of applications and use cases you can implement just based on this data and having these SBOMs.
Awesome, thanks for that.
Of course.
It doesn't look like we have any more questions from the audience there. Yakve, anything else on your end?
No, not from my end.
All right, nothing else from me. Dimitri, any last words before we close it off?
Well, yes, thank you for staying with us, and thank you for joining us today, and happy to be here. And if you need any question, you have any questions, or you want to learn about this topic, or you want to participate in and contribute, right, to the SBOM working groups and efforts worldwide, reach out and join the people.
Okay, just before we close it off, do you have like a way that people can reach out to you if they want to? I didn't see it on your presentation. Just wondering if you want to post it to the chat.
Yeah, and that's a good point. So you can reach me at Dimitri@cybeats.com. That's my email. That's one way to reach out, or on LinkedIn, right?
All right, let me just take that and put it into the in chat here. All right, awesome. Yeah, thank you very much, Dmitry. We very much appreciate you giving us a talk on SBOM. And big thanks to our sponsors as well in the audience. Don't forget to leave feedback and CPU credits if you're looking for it. Take care, everyone. Take care, Dmitry. Have a good one, and we'll see you next month.
Thank you. Take care. Bye-bye.
Thank you. Have a good one.